If we can't make humans more logical, can we at least make logic more human? I'm Ray Myers. Welcome to Craft versus Cruft. And as I keep saying, this is 2024, the year of formal methods. And I'm going to build on something I introduced earlier in episode 38, which is first order logic. This is kind of a continuation of that line of thought. In that episode, I showed you how you could take a logical argument and formulate it in either propositional logic, also called zeroth order logic, or in predicate logic, also called first order logic. We showed some of the ways those are represented in symbols like you'd see in papers, and also converted it into Z3 to run in an actual prover that can validate whether it logically holds. And people sometimes say you can prove anything with logic, right or wrong, and that's true. But nonetheless, I think that logic is a phenomenally useful tool to deconstruct what the argument it is that you're making and to present it to people in a way that they can understand exactly what parts they may agree or disagree with. So given that I think it's so useful, I thought I'd try my hand at making it easier. I wrote a little script yesterday. I'd like to show it to you. So this is an example of just an argument stated informally in English. This is a classic example of the syllogism they teach, right? All men are mortal. 2, Socrates was a man. Conclusion, Socrates was mortal. Now, you can't validate this in a prover as written, but if we turn it into first order logic, predicate logic, for instance, we have for all x, man x implies mortal x. 2, man Socrates, conclusion, mortal Socrates. That formally validates. You can convert that to the notation used by any number of automated theorem provers, and it would be able to tell you that. And it turns out just converting an individual line of statement to its form in logic is something ChatGPT is not like perfect at, but relatively good. And I made a GPT called first order logic that's in the GPT store you could use, or you could just write your own prompt or use mine. For instance, I give it this prompt and it says, okay, I'm going to break this down. Propositional logic would look like this. Predicate logic would look like that. Great. So it was able to reproduce this just fine. I even added a command here for using Python and the NLTK library to try and run this in a prover directly in ChatGPT. As you can see, it was able to do it successfully in this case. It outputs check true for both of these. But I've had kind of mixed results. I think this is promising enough to move to something a little more custom than a GPT's store thing you're able to guide with a prompt. So I wrote this little command line tool. Let's check it out. I'm going to run it here. So we are now in first order logic assistant shell. The repo is human logic. It's online. So we're in our little first order logic assistant shell. The repo is human logic. That's on GitHub. I'll link it in the description. All right, so let's just start out with a really basic one. So for instance, all mammals are animals. So it has quickly called OpenAI and converted this sentence to its equivalent in predicate logic. So I didn't have to know that this is how this looks in the notation, right? It just made that line for me. So now I can have exposure to what my statements look like in this notation without having to know exactly how to construct it myself. Though if it makes a mistake, I will have to check it. Then I can add a statement. I can give it a number if I want. I leave the number off. It'll just add it next. A cat is a mammal. All right, so we have for all x, mammal x implies animal x, and we have for all x, cat x implies mammal x. So conclusion, a cat is an animal. Resolve that, and fantastic. So currently it's just showing you it in this notation. It's not actually checking that this holds, but I'll show you that it's relatively easy to get ChatGPT to convert it to Z3 notation that is usually pretty usable. Can you write this in SMT-lib2 formats. All right, so it is the Z3 prover, but the syntax native to Z3 is called SMT-lib2. It's also used through various programming languages using another interface, so that's why I'm specifying that this is the format specifically we should use. Okay, yada, yada, yada. It's explaining you can't really conclude in Z3. It's a satisfiability program, so you have to negate the conclusion and assert that it doesn't satisfy. I'm going to just say, yeah, do that. And this is the answer it's giving me for that. Let's take it into the playground just so we can show you, does it work? And it runs no output. That's actually okay. I can say check sat. It says unsat. If I comment out the conclusion, now it's satisfiable. So assuming this is a legitimate conversion, and I believe that it is, of that logic into this syntax, then those two facts together show us that this is a valid proof, that it's satisfiable when we comment out the conclusion, and it's unsatisfiable when we put in the negation of the conclusion. If you can't satisfy a situation where the conclusion is negated, then that means the conclusion must hold. But it's also a little cumbersome to do all that. So if that's the normal workflow that we want to have happen, then obviously we could have this tool just make that conversion for us, and then run Z3 for us in the appropriate way, and really be a proper interactive prover. Nonetheless, if you want to play around with this as it is, it's in a little repo called Human Logic, like I said, and I will show you some of the things that are in this code. It's relatively short so far. I might keep adding to it, or I might take other similar directions. I'd love to hear your thoughts and what other tools exist that maybe we could think about integrating with. Generally, the idea is to provide a very easy on-ramp onto formal methods for developers and maybe other people. So here's the code here. I'd like to just draw attention to a few of the moving parts here. There is a Python library called CMD, which is very useful for sort of interactive command line apps. So not command line argument parsing, but an actual just interpreter loop. You make a class that subclasses CMD, you define various actions, your prompt, your introduction, and then it kind of handles the loop for you. It's pretty nice. I'll probably at some point rip this out and re-implement it just so I can integrate the rich library and have nice colors and things. Of course, we're calling OpenAI, but there's a special thing about how we're calling OpenAI, which is that we're also using the instructor library. OpenAI offers their function call API for getting structured JSON in a response, but I can use instructor also to put it right into a Pydantic model. So I can go right from that JSON LLM output to my data objects and know that it's all been validated correctly. With this library, the way that you use it is by running this patch, which is a little sketchy to me, but I did like the results of the OpenAI client. And then when you use it, you can give it a response model and say, this is the model that you should be returning, and just put all the JSON fields onto there and make sure they validate. So then our function just returns that domain model. There are a number of other libraries worth looking into for constraining LLM output. One of them is Marianne.AI, another is Guidance. But generally having some kind of guardrail that puts explicit structure onto LLM output is very helpful. Another thing to point out, in my OpenAI model selection, I am currently using the GPT-4 Turbo latest preview. Now, GPT-4 Turbo is cheaper and faster than GPT-4, but stock GPT-4 is considered the stronger model for a lot of use cases. However, I'm also doing myself a lot of favors with the use case here. I'm only sending one line of a logical statement with a very limited set of things it can be turned into. So I don't think you'd be limited to using a 4 or a 4 Turbo with this. I think easily GPT 3.5 Turbo would be able to handle this, or a number of the competitors or open weight models. We're keeping a relatively small scope on what we're expecting out of an LLM for this use case. Now, this is the main prompt I'm using. As you can see, I've said specifically I would like these to be the logic symbols in question. However, it does occasionally use the LaTeX commands, and so I just have a formatter that replaces those, no big deal. Something else I'll point out here that I'm using a line editor that was actually inspired by the experience of using IBM PC Junior Basic, Cartridge Basic, which is that you input a line by typing the number. So you can replace a particular line by beginning with the number that you want to replace, or in this case, C is like a special number for the conclusion. And as a result, you can also delete the line by putting a number with just no replacement, right? So we can clear that out. Now, line editors are mostly a historical relic before we had screen editors, though there are some interesting line editor capabilities still embedded, for example, in Vim. But lately, I've been thinking a lot about line editors and generally command-based editing because I've been thinking about other users besides humans. It may be that a script is driving the editing as part of some larger workflow, or it may be that the user is an LLM, and then screen editors are not so good anymore. So that's something worth thinking about. I've been really fascinated by the tool Cursorless, which is a workflow for programming with voice that relies heavily on command-driven editing. So I hope you enjoyed this little exploration into semi-formal methods. Let me know what kind of directions you've been thinking about. And as Lao Tzu said in the Tao Te Ching, with patience, the most tangled cord may be undone.